Okay, so today's lesson is lesson 6, determining area and perimeter of polygons on the coordinate plane. So we've been looking at some irregular figures and using different approaches to find their areas. Today we're going to continue on with that, except this time some of the figures are going to be on coordinate planes. So if you look at example 1, it says Jasji has made a scale drawing of a vegetable garden she plans to make in her backyard. She needs to determine the perimeter and area to know how much fencing and dirt to purchase. Determine both the perimeter and area. So looking at this figure, I'm going to start with the perimeter. And to do that, I have to find the length of all of the sides of the figure. So from A to B, I can just count 1, 2, 3, 4 for length there. From B to C, 1, 2, 3, 4, 5, 6, 7. From C to D, 1, 2, 3, 4. D to E, 1, 2, 3, 4, 5, 6. E to F, 1, 2, 3, 4, 5, 6, 7, 8. And then from A to F, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now if I want to find the perimeter, I just need to add all of those numbers together. So I've got 13, 4, 7, 4, 6, and 8. Add them together. You can use your calculator or you can use any strategy that you have. Personally, I would find 10, so 6 plus 4 is 10, 7 plus 3 is 10, and then 8 and 4 together make 12. So I'm adding 10, 10, and 12 to get 32. So the 2 goes down, the 3 goes up, and my perimeter would be 42 units. So that is your perimeter. You just have to find the length of all the sides and then add them all together. We also need to find the area of this figure, so I'm just going to erase the perimeter work. For the area, there's a few different ways we can do this. We can split the interior of this into 2 rectangles, or we can work around the outside. So I'm going to show you all of the different ways that that's possible, and in the long run, you just choose which one you like best. So one way I can do it is I can split it into 2 rectangles with a horizontal line here. So if I'm to find the area of this figure, I can see it's 4 across here, and then from B to C was 7. So this would be 4 times 7 in this rectangle. And then down here in this rectangle, I have 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7, 8. So it'd be 6 times 8. So if I do this, area equals length times width, 4 times 7 for the top rectangle, which is 28. For the bottom rectangle, 6 times 8, which is 48. Add the 2 together and get 76 square units. Okay, so that's one possible way of finding the area of this figure. Another possible way to find the area of this figure is splitting the inside just a little bit differently. So I'm just going to shoot to my next page here. Instead of splitting horizontally this way, I can split vertically this way. So now I have a 4 by 13 rectangle on the side, so 13 times 4. And over here I have a 4 by 6 rectangle, so 4 times 6. Again, length times width gets us those areas, so 13 times 4 is 52. And 4 times 6 is 24. Add the 2 together and get the same 76 square units we got previously. One other way that we've seen to do this is to compose a rectangle around the figure. So I'm just kind of finalizing the big rectangle. So I've made this large rectangle that I can find the area of. I know this side length is 13. I know this side length is 8. So I would find the area of that rectangle and then subtract out the empty space, which would be that rectangle. So this rectangle is 4 by 7. So I would do my length times my width, or 13 times 8 for the larger rectangle, which is 104. And then for the smaller rectangle, the one that we're going to end up subtracting out because it's open space, I would do 4 times 7, or 28. To find the area of the shaded figure that we were looking for in the beginning, 104 minus 28. Which again, still gets you that same 76. It doesn't matter which one of these three approaches you use on this. That's why I wanted to show you all three. You can pick and choose whichever one you like best. So the next problem is asking us to calculate the area of the polygon using two different methods. Write two expressions to represent the two methods and compare the structure of the expressions. So basically, one is where we can deconstruct the figure into shapes inside, and one is where we're going to compose a rectangle outside and subtract out the empty spaces. So if I were to look at this, the way that I would break this down inside would be to draw a line here and to draw a line here, which would create two triangles and a rectangle. So in this case, I would find it easier probably to do the rectangle first. Length times width. We've got 4 this way if you count across. 1, 2, 3, 4. And then on the other side we have 1, 2, 3, 4, 5, 6. So for the rectangle, I would be doing 4 times 6 or 6 times 4, doesn't matter. I'm getting 24. For the triangles, we can consider this side our base, because we can then run our height from our base to the opposite point right here on this line to get our height. And they're both going to be the same size triangle. So again, triangle is base times height divided by 2. If we count out our base, which is already done for us, it's 6. And our height is 1, 2. So 6 times 2 divided by 2 gives us 12 divided by 2, or 6. So this is also the same base and the same height, 1, 2, so I don't really need to do more work for that one. I just have to account for 2 of those when I add up. So I would have 24, 6, and 6 for the two triangles. Altogether, that gives me 36 square units. Now the other method of doing this would be to draw a rectangle around the outside. Remember, when you draw your rectangle, you want it to hit through all of the points of the figure along the outside. So that would be your rectangle. So first I would start by finding the area of that larger rectangle along the outside. I've got to count my length and my width, so it's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So the area of the rectangle is 8 times 6, or 48. Now what I need to do is look at my triangles. So I've created 4 right triangles along the outside that I'll need to subtract out their areas. So I can look at it as base and height. So I've got 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. So once again, they're all the same size triangle. So this time when I do my formula for the triangle, I'm only going to do it once. Again, I'm taking my base and my height, multiplying them together to get 6, and then dividing by 2 for the area of a triangle formula. That says each area is 3. I have 4 of those triangles, so I'm going to do 3 times 4 to get a total area of the 4 triangles at 12. Now what I'm going to do is I'm going to take the area of the rectangle that I created around the figure, 48 and subtract out the total area of the open spaces, which was 12, which gets me that same 36 square units that I got in the other problem. So now what you can do is you can use these ideas to answer the questions in your Playposit. Again, it's up to you if you want to break it down on the inside or make a rectangle around the outside and subtract out the open areas. Good luck!